We're seeing how to open this file and to get its content as just one string, which we call it the content. And now we want to actually parse it and to work with the data structure that we can actually work with and manipulate and do some calculations with. Because just a bunch of a long string is not something we can really conveniently work with when we work with data. So we want to take all of this data, which is currently stored in this file, in some format, and we want to convert it into some useful data structures. That is called the parsing of the data. Now, when we parse data, the first thing we need to consider is what data structure would it make sense to store the data at? Like, what do we want? How do we want to store this data so it would be convenient for us to work with? Now, maybe without looking at the code at the notebook, maybe you can try to think and give some suggestions as what do you think would be a good data format to store this data that we have here? What did you say? A table. What do you mean by a table?
An axon, one start position, end position. So you have like 3 columns. Column 1 is the axon number. Column 2 is the start position nucleotide. Column 3 is the end position nucleotide.
Okay, you suggest a table, but we work with Python. So can you suggest a Python data type that you think is appropriate? A dictionary, you say. How would you use a dictionary to store this data?
It depends if you want to number them.
What did you say? A list?
A list of tuples of start and end, and then you can also sort them like a set or something like this, and then.
Okay, yeah. So there is a suggestion here to use a list of tuples. So each one of these, maybe the 2 coordinates will be pairs, which are stored within a tuple. And then if we want all the exons, we can put it in the list. So that would solve the exons problem. But what about these kinds of fields? How would we store them? Strings? Like 3 strings, 1 string? And like the string would just be the raw values, like everything, like excision, tab, then the ID. Would it be convenient to use it this way?
No, because if they're raw, then you see a lot of the T and N and all the commands that you don't want to see in the middle. So it would be like accession, \T, and then NM. So you want it not in a raw kind of.
Yeah, so how maybe, what kind of data structure would it be more convenient for us to use?
Dictionary.
A dictionary. How would you store it as a dictionary?
Accession is the key, the value is NM, and so on.
Yeah, that's a good idea. Yeah, we can just put, like we can use 2 different variables. We can use one variable for the axons, which like Ray suggested would be a list of pairs. And then we can have some dictionary which would store these kind of more general fields. And this is actually what I did here in this example. So I decided to take all of these and call those the meta fields, which are the 3 ones here, as a dictionary, and the axons as a list of tuples. So yeah, and now of course begins the actual work of, we know what kind of data structure we want to get into. We then look at this format and see like how it looks and how the data is stored in this format. And then the question becomes just how we move from the existing data format to the kind of data structure that we want it to be in. And that's what we do when we parse data. So let's see how we can do it here. So basically, we split it by lines. Okay, this is one method I showed you earlier today, to separate it by line and then work with each line separately. Then there is the split kind of, the split function, which I said was extremely useful, and you can see some example here. So I give it a /t, which indicates a tab. So we want to split it by tabs. You see that everything is separated by tab, and by using the split, we can just get the left-hand side and the right-hand side. And we know that there should be exactly 2 parts, so we can put the first one and call it a key, and the second one call it a value. And then there are two cases. So if the key is axon, like the last lines, then we know that the value is itself should be like start double dot and then an and. So we can split it by these two dots. And again, we use the split function. And we put the first and call it start, and the second we call it and. And then we convert them to integers, put them within a tuple, and this tuple we stick into this axons list. Otherwise, if it's not an axon, then we just take the raw values. We put it in the meta dictionary, and we say meta key equals value. And now we get everything we want, and we can iterate over it, and you can see that we got the meta fields correctly, and we got the axons correctly. Okay, so this is somewhat of an art that you learn the more you program and the more you get to parse different data files. This is something you're going to do a lot in this course, to parse data. Of course, sometimes you will get to work with data in existing format, and then you might have some library which you can use, which parses the data for you. But very often, people make up their own formats, and there is really no way around it. You just need to take it, and like you see here, using all kinds of string manipulation functions to actually parse the data. But again, like I said at the beginning, like the most crucial decision that you make when you parse data is what data structure you want it to be at the end. So that's like should be the first question you ask yourself whenever you come to parse data, and then like everything else, I think flows pretty much naturally from there. With just some different tricks you can use to extract the information that you want. Any questions about this parsing process which we did here? Okay, so now that the data is parsed, we can do all kinds of calculations and analysis that we might want. For example, here I create a new list, which I call it axon lengths, and I just put in not the start and the end, but the lengths of the different axons. So I use the calculation of end minus start plus 1. Do you know why I need the plus 1 here? This is related to the fact that what I explained to you at the first lesson, the zero-based versus one-based index, which is very different. So in zero-based index, what we usually use in programming, actually the length of a range is the end minus the start, because the convention is that the end is not part of the range. So it's all the way from the start to end minus 1. So you don't need this plus 1. But when we work with one-based indices, which start with 1, actually the convention is that the end is part of the range that you work with, so you need to add this plus 1. So again, every time you work with indices, always pay attention to whether it's zero-based or one-based index. Like this is maybe the most common bug that people work with biological sequences make, tending to confuse these two kind of different indexing systems. Yeah, so and then we can take these lengths and do all kinds of calculations. We see that there are 23 different axons. The minimum length is 41. The maximum length is over 3,000. And the average is about 300. And now, if we want to save something to a file, this looks pretty much similar to reading. Again, you use the open function, and you give the path of the file that you want to create. Now here, you need to make sure that you provide it within a directory that already exists. Okay, if you try to open a file to write within a directory that won't exist, it will give you something like no such file error or something of that sort. So make sure that the directory exists. But on the other hand, make sure that the file doesn't exist. Or if it does exist, make sure that we really want to override it. Because as soon as you run this statement, okay, even if you do nothing else afterwards, as soon as you open a file in writing mode, it will already erase a file if it exists with that name, okay? So if you had such file before, it will automatically erase it and create a new empty file as soon as you run this command. So make sure that, typically you don't want to delete anything, so make sure that the file doesn't exist, but the directory does exist. And crucially, you see that here in the mode, instead of an hour, we give it a W, which means we want to write. Okay, so this is a different mode. And now instead of using the function read, we use the function write. We can just give it a string, and it will take the entire string and dump it into the file. And this will be the new content of the file. So in this case, we take this list of action lengths, and we convert it to string, which give us a string representation of the list. Sorry. So that's what we get. So we get the string representation. We just remove the first and last characters because we don't want these brackets. And we write it as it is to a file. And then, of course, we close. Super important, especially when we write a file. And now if I go to see downloads, you can see that I have this new file called action lengths. And I can open it with Notepad++. And you can see that I have all the lengths here. OK, questions? OK, so to wrap up this lesson, I want to show you just a few more, couple of new other modules, which I think could be useful for you. The first one, which is directly related to this working with the file theme, is the OS module, short for operating system. So depending on which operating system you work with, you will get access to some functions that give you to do various things with that operating system. So in the case of Windows, we can, for example, invoke some Windows commands. And it's also very useful to work with file and directory paths. So for example, we have the OS path submodule. So path is yet another module within the OS module. And this path submodule has a function which is called join, which given some directory path and then maybe some subdirectory or a file within that directory, it simply joins the two paths together. So you don't need to worry about all of those forward slashes. It basically just takes this prefix and this suffix and plugs it together, and then you get c, temp, dir, something, file, txt, all as one path. So if, for example, you work with the same directory and you want to get a path of different files within that directory, it's recommended to use the OS path join function instead of like manually trying to manipulate the strings to concatenate them together or something like that. This will be a more robust way to do that. You have the list_dir function within the OS module, which given some directory path, it will just give you all the files that exist within this directory on your computer. And you have a very general command, which is called the system, which will allow you basically to run any command. So if you work with Linux, it will be any Linux command. And with Windows, anything that you can run on a command prompt or the CMD terminal, you can run here. So for example, if I run calc, this will open the calculator for me. No reason to do that, but just to give you an example of that you can basically invoke anything you want from within Python. OK, and finally, the last thing I wanted to show you before we move to the lab exercise is a module which is called collections, which provide you even more kinds of more nuanced collection types, and specifically two collections which are called counter and defaultdict, default dictionary. So let's see what they are good for. Let's begin with the counter. So a counter is you can think about both data structure, both the counter and the defaultdict, as some kind of some version of a dictionary, just with some default values. So in the case of a counter, you can think about it as a dictionary with a default value of 0. So it's useful to count things. OK, so for example, say I have this amino acid sequence. So I create a new counter. OK, and then I can just go over each amino acid in this sequence and access the entry within this amino acid and increase it by 1 to count how many of each amino acids occur. And as you can see at the beginning, the counter is empty. And by the time we are finished, it gives us the count of each residue in this protein sequence. OK, so this is actually useful. It's more convenient than just to use a dictionary, because if we use the dictionary, we would have to worry about the special case of the first time we put an entry. So each time we got to an amino acid, we would have to do something like if AA in AA count then increase it by 1. Otherwise, okay, the first time we encounter an amino acid, we don't have an entry, so this would give us a key error if we were used a dictionary. So we could do something like that, okay? So that's probably the way we would do it if we worked with a dictionary. But again, because the AI count by default puts everything to 0, you don't need to worry about this special case, and you can just assume that everything exists, and if it doesn't exist, then Python will know how to handle it. Any question? Okay, and actually the counter is even more easy to use than that. You don't actually have to iterate yourself through everything in your sequence. You can just actually give it in the constructor of the counter. And when you give it a list or a string or anything that has elements which you can iterate, it will just count how many times each of these elements occurs. So if you give it a string, it will count the letters in the string.
The type is a dictionary?
No, the type is a counter, which is very much like a dictionary, but it's a different type. Yeah. And yeah, like I showed you can use the plus equals to increase the value by any number you own. So if we increase it by 1, we get A increasing by 1, but we can also increase it by 3 if we want to, and it will increase it by 3. So if we want to query something from a count, we do it just like with a dictionary with square brackets. So if we give something that exists, we just get the value. But if we give it something that doesn't exist, like I said, it's default 0. So anything that doesn't exist, unlike a dictionary, which will give you a key error, here you will just get 0 as the default like count. And another useful function that it has is the most common, which will give you a list of pairs, a list of tuples, with the most common entries that you get. So if we limit it to 5, like in this case, we'll get the 5 most common amino acids. And you can see that it's A occurring 15 times, then E 12, L 11, and so on. We also have the update function. If we want to update something like multiple entries at a time. So if we give it a new string, it will then use the string to update the counters. So it will add A twice and then L 3 times and update all the counts. And like I said, the counter, you can just think about it as some kind of a special dictionary. But if you want, you can convert it back to a dictionary and get a dictionary. Okay, so we can use the dictionary constructor to convert the counter into a dictionary. And of course, you can use it not just to count letters in a string. So if you want to count something else, you need to provide it as a list. So for example, if we take this sentence and we split it by spaces, we'll get a list where each word is a different element in the list. And if we do counter on that, we will get basically the count of each word. Okay? So you can see how many times each word occurs within this string. So that was counter. And even more generic kind of data types is what we call a defaultdict. And actually, counter, you can think about it as just a special case of a default dictionary. But a default dictionary is even more generic. A default dictionary is a dictionary that every time you try to access a key that doesn't exist, you will get some default value depending on what type or function you give it. So for example, if we give it a list, we want a default dictionary of lists. What it basically tells Python is that every time we try to access something that doesn't exist, just give us an empty list, and we will continue from there. So for example, say that, again, we take the same amino acid sequence, and we want to create some index that specifies for each amino acid all the indices, all the locations in the peptide in which this amino acid occurs. Okay? So we can create this defaultdict of list, and then every time when we access an amino acid, we can just get a list and append it the location, the index, and we don't need to worry about the case where it doesn't exist yet. Because if it doesn't exist, it will just create an empty list, and we can start from there. Okay, so you can see we indeed get what we expect. We get a dictionary-like object. It's actually defaultdict. It's not a dictionary. And each amino acid is mapping to a list with all the places that this amino acid occurs. Okay, and if we try to access something that doesn't exist, like Z, there is no such amino acid, then we just get an empty list. Okay, because this is the default we specified. And again, if we really want, we can convert it to a dictionary, although the two data types behave pretty much the same. And yeah, and basically we can, the defaultdict accepts not only types, it accepts anything, any function that you give it which creates something by default will be a valid input in the constructor. So for example, we created this function which we call createEmptyCounter, which creates an empty counter. And when we call a defaultdict with this function, what it means is that every time we try to access a key that doesn't exist, Python will call this function, we'll get the return value, and that will be the default value, which we can then continue from there. So in this example, for what I did was we create this dict of counters that for each amino acid gives you a counter of the next amino acid. Okay, so you can see that, for example, for the M is followed by Q one time, it's followed by E one time, by S one time, and so on. So each amino acid you can see like all the things it can be followed by and how many times it happened. So the way we do that, we iterate through both the index and the amino acid of this sequence, all except, of course, the last letter, because it's not followed by anything, using the enumerate function, which we saw earlier. And then we use this index to get the next amino acid. And then we go to next AA counter at position amino acid, which will give us some counter, by default an empty counter. And then we go to this counter in position next amino acid, and we can increase it by 1. Okay, so here we have like a nested kind of structure, which combines both the defaultdict and the counter. And if we were to use just vanilla dictionaries, it would be quite a complicated code to do that, because we would have many ifs in the code to make sure what happens if the amino acid doesn't occur, and then what happens if the next amino acid doesn't occur within this outer dictionary, and it would be a lot of if-else statements. But here we don't need to worry about it. So yeah, of course here I put this a function because I wanted to demonstrate that it could be any function, but of course in this case it's completely redundant. I could have replaced it with just a defaultdict of counter, and it would basically do the same thing. So I think that's it. Any questions? Okay, so we'll stop here and move to the lab exercise.